Good morning, good afternoon, good evening, from whichever part of the world we're connecting from. My name is Bukola Orunti, and I'm the instructor for this course, Network Operations 1.0. So this is to record the first week that we couldn't hold due to low turnout. So once again, my name is Bukola Orunti, and I'll be the instructor for this course. Now we are treating Module 1, which is Introduction to Unix and then Introduction to FreeBSD. So let me start with the first part, Introduction to Unix. The objective for this course is to describe the characteristics and architecture of Unix. The second point is to distinguish between Unix operating system and Unix-like operating system. The third point is to explain the security model of Unix. And finally, to discuss why network operators prefer Unix, or what we also know as Linux operating system. Now, overview of Unix. Well, Unix is an operating system that was initially developed by the Bell's laboratory, and Unix is known as the most powerful and popular multitasking and multi-user operating system. Multitasking simply means it can do multiple task operations at the same time from the same machine or from the same operating system. Multi-user also means that multiple people can connect to that same machine at the same time. So it doesn't affect one another. People are doing different tasks, running different applications at the same time on the same machine. Also, we believe that it is known that Unix has different variants. Also, we know there are Unix-like variants. So now, how do we differentiate between Unix and Unix-like? Unix variants are simply other versions of operating system that came from the source code of Unix. And Unix-like are other operating systems that came out from Unix, either from Unix source code or that was developed parallel to Unix. They are not from the same source code, but then they also have the same features as Unix. So they are referred to as Unix-like variants. Another key thing about Unix or Unix-like is that Unix operating system strictly follow the standard of Unix, while Unix-like do not necessarily follow the standard of Unix. Now, let me share my screen and so that I can use a slide that is available for this. Okay. I hope my screen is visible. Okay. Okay. Apologies, I'm trying to hide this. So now let me see if I can hide this. Okay. So I guess we might have to manage it if I can't hide this. So, okay, I've gone past this slide. So, yes, I've done this. The Unix overview, it's multitasking, multiple user is believed to be powerful. And okay, this is a historical development of Unix. Yes, it was actually developed in 1969, and the development team was led by Ken Thompson and Dennis Ritchie, because at that time they worked at the Bell Laboratories in US. Now, in the late 1970s stroke 1980s, one of the lead teams, I think that should be Ken Thompson, now moved to the University of California, lecturing there. And then I guess based on his teachings, a group of academics now came together and developed another version of Unix. And this was developed by the team of academias in Unix, and they refer to it as BSD, that is Berkeley Software Development Variant. And so that was how open the open BSD, the free BSD came to be. This was the Unix version that they developed, and it was targeted at commercial startups. So in the early 1990s, an American multinational software company known as Novell, they bought over the rights of Unix from Bell's laboratory. Then the Novell organization now transferred the Unix trademarks to another consortium known as the Open Group. Now, what the Open Group eventually did was now they developed a standard for Unix trademark, and the standard is known as SUS, simply means single Unix specification. So for any Unix operating system or Unix variant to be able to use the Unix trademark, they have to be certified using the SUS standard. So if it's not certified to be using the SUS standard, then they can't use the Unix trademark. And that is why they are referred to as the Unix variant. Now, if they do not conform with this standard, they are referred to as Unix-like. So examples of then Unix variant, that is, they came directly from Unix open source. These Unix code, the variants that were developed, or other operating systems that were developed directly from Unix source code, they are the Minix, they are the BSD, that is FreeBSD and the OpenBSD, the Solaris, the Mac OS, the AIX, and the HPUX. But out of all these, we will later realize that only, I think, 2 or 3 of them actually complied with the SUS standard. So they are the ones that are actually referred to as the Unix variants because they comply with the standard, and also they are the ones that are allowed to use the Unix trademark. Yes, others were developed from the source code, but then they are not in compliance with the standard, the SUS standard. So we'll see those ones later on. Now, the Linux operating system, I'm sure most of us have heard. If we have not used, we've heard about the Linux operating system. Now, this was an operating system that was, how do I know, maybe conceptualized, or the idea was battered with the performance of Unix. So a man then known as Linus Torvalds in 1991 now developed his own operating system from scratch. In this instance, he did not use the source code of Unix. He developed his from the scratch, but I'm sure the idea was battered from the performance of Unix. So Linus Torvalds in 1991 developed another operating system that has the same capability of Unix and named it Linux. Now, let us note, they are not from the same source code. He developed his own right from the scratch. And now, today, since they virtually have the same capability, the same strength, the same performance, people interchangeably refer to Linux, Unix. They use the word interchangeably. But actually, we need to understand that there's a clear difference between these two operating systems, even though they have the same strength and they can work almost the same way. Today, we have different versions or distributions of Linux. Example is Ubuntu, we have Fedora, we have CentOS, we have Red Hat. Debian, even Android. All these are distributions that came from the source code of Linux. And large enterprises, large organizations today, they make use of this operating system. We have Peugeot, they use it, Google, Amazon, KLM, and other big organizations have Linux operating system running at their core. Okay, like I said earlier, Unix-like operating system or Unix operating system that came out from Unix source code in Minix, the BSD version, that is the FreeBSD and the Open BSD and the HP. But the clause here is that they do not conform with the SUS standard. So they are not referred to as Unix variants, but rather referred to as Unix-like operating system. Out of the ones I mentioned earlier, it is only, I think, Mac OS and Solaris or one other OS that actually confirmed with the SUS standard, and these are the ones that are allowed or permitted to use the Unix trademark. Now let's move to the next subtopic that says the Unix system or the Unix architecture. Now I want us to understand that both Unix and Unix, like that is Linux, they have the same architecture. So if I'm talking about Unix or Linux, I'm actually referring to the same architecture in terms of the OS architecture. The first one, the base of the pyramid, is the shape of the pyramid. The base of the pyramid I'm starting with is the hardware. Now, the hardware is a collection of physical elements that constitute a computer system. So it's actually what I would say the physical part of a computer system or any device, any smart device that we interact with. So in this case, I'll use the word computer system. So example of the hardware is the CPU. And then in the CPU, we have the motherboard, we have the memory modules, we have the microprocessor. These are the physical parts of a system that we actually interact with. Now, directly on top of the hardware is a kernel. Now, the kernel is the master control program of an operating system, and it has full control over the entire system. Why? It has subsystems that manage even the entire system and the resource handling. It controls the memory management and other low-level core tasks of the operating system. So when a system starts up, the first thing it does is it loads the kernel of the operating system to the memory. I'm sure in the old days when you were trying to put together a CPU, like a tower casing of a CPU, when you're putting it together, and peradventure in the course of putting it together from the motherboard and the likes, you forget to install the memory. The first thing that happens when you try to power it on, it gives a beeping sound to tell you that it cannot proceed or it can't load the next thing because the memory is missing. So it's just like it gives a beeping sound or an alarm. So the reason being that the operating system can only load up by moving it from the hard drive to the memory for it to boot up. So that's the first thing it does. The kernel loads into the memory and then before it proceeds. Now, directly connected to the kernel is a shell program. Now, the shell program is a program that acts as an interface between the user and the kernel. It interfaces between the user and the kernel. For example, I'm working on a system or Unix system or Unix device. I cannot directly put command into the kernel for it to carry out. So I run it through the shell program, and then the kernel is actually the one that performs this, executes this command. So the shell uses a command line interpreter, which we also know as CLI, that allows the user to enter commands and then execute those commands to the operating system. So in Unix, many shell programs are available for the user if it's installed in the operating system. Some come by default, some we have to install. Example of shell programs in Unix or Linux, we have the Bourne shell, denoted SH. We have the born again shell known as bash. We have the C shell known as CSH. We have the corn shell KSH, and we have the Z shell ZSH. And then one common thing about all these different types of shell programs is that for non-root user, there's a way you know, okay, I'm working as a non-root user, and there's a way you also know I'm working as a root user. There are different symbols that differentiate between these two categories of user. Root user in Unix or in Linux is also known as administrator or super user in Windows. So for a non-root user, for most of these shell programs, it's denoted using this symbol dollar with a single slash. You know the dollar sign, you know in dollar sign is double slash crossing the S, but in this case a single slash crossing the X. And then for the root user, we know what we refer to as the hash sign. So when you get to the shell prompt and you are seeing the hash sign, it simply means you're working as a root user or as a super or administrator. So you must be very mindful of what you do, the commands you execute at every step. Now for the non-root is the dollar sign. And then for C shell, which is only different for the non-root, I think the C shell and the Z shell, they have this percentage symbol. And you see the percentage, you know, you are a non-root user, and then you could either be in Z shell environment or a C shell environment. And on the peak of the pyramid, the topmost part is the command processes. This is the outer layer of the operating system, the Unix or Linux operating system architecture, and it consists of command processes. There are user processes and there are system processes, both inside the command processes. Now for the user processes, we also refer to them as the application software. These are programs that the user will run to execute tasks. For example, I need to browse to solve the internet. I'll need a browser. So example of application software that runs in this at this point is a web browser. We have the word processing or the word processor and the likes. Now the second type of command process is the system process, also known as the system software. These are programs that run in the background, and in Linux or Unix we refer to them as daemons. These are exactly the processes of the software that support multitasking. So you can be running different background programs, and then it doesn't affect you as a user that you're doing something else, something totally different. Example of such common daemons is the syslog D. This is the process that implements the system login facility. And then the SSHD is a daemon that or service that manages incoming SSH connections, especially for remote connections. Now we'll move to the next subtopic, which is known as the security model. That is the Unix security model. Now, each operating system has an underlying security model that controls access to different components on the system. In Windows, it has its own, and Unix or Linux also has its own. These are the ones that control the file system or the directories. Will it give you access? Will it not give you access to a particular file, to a particular directory? Unix has its own security model. Now, a security model also defines user categories and their respective privileges assigned to them as group or as individuals. So, as an individual using a particular system or device, Unix has provision within its operating system that allows user A to access all or limited parts of directories or file system with files within the system. So depending on the category of group or user that such user A falls into. Now, let's start with the first one that says user and user groups. Each user logs in with a valid user ID. So that's very important. Just like in Windows operating system, you can either log in as the administrator, or you can log in as a guest, or they can even create your own personal account for you on that system. The same thing is applicable in Unix. So each user that logs in will log in with a valid user ID that is identified on the system. And then there's provision for user ID and then for password. You can choose to add password, you can choose not to, but then the provision already exists. So a user may log in via an attached keyboard to the Unix machine or the Linux machine, or via remote connection, like I said earlier, via secure shell, SSH. So the user ID and password are in Unix or Linux, they are very case sensitive. So you can't afford to not be mindful of the case that you are using to put in your username or your password. If you start your username with a capital A or a capital letter, and then when you want to log in, you're now using a small letter, it will see it as another user entirely. It will either tell you such account does not exist. And the same thing when you're inputting your password, be mindful of the case of the password that you're putting in. Also, a user can be a member of different groups, and these user groups are identified with a numerical value. You identify it as GID. The user ID and the group ID are usually 16-bit numbers in older operating system, while in modern ones, they are 32-bit or 64-bit. So I'm sure most Unix or Linux operating system that we see today, most of them will be either in 32-bit or in 64-bit. Now, the user ID and the group ID are mapped and stored in plain text files. So when you go to /etc/password, you'll see the user ID information there, or /etc/group, you'll see the group information there. So this is an example of user account information going to /etc/password. Look at the first line there. We have the root, that's the username. Then the X after the full colon is to tell you that the password has been encrypted. Then the O is for the user ID. The next one is for the group ID. O is actually reserved for root user. And then the next one is the comment, and then the root path, and then the shell for the root user. So the next one, okay, yeah. So then we have the user privileges. Now, for the user privileges, we have the root user or any other guest. In Windows, we refer to them as guests. So for the root user now, this is equivalent to, like I said earlier, administrator user in Windows, and it is the super user of the Linux system. It has full control over the system. It can perform any activity that I choose to. Some of them that I would just like to talk about, it can do the read, it can do write, it can delete, it can execute all files and directories, regardless of their permission settings. So as a root user, you must be very, very careful what you're doing or what command you are inputting. You can change permissions of any file or directory. You can add, remove, or update any Unix or Linux user group. You can mount or unmount any device mounted or owned even by any of the other users on the system. You can access any device connected to it. You can change the priority of any task running. You can stop, you can abort any task running. You can change the user ID associated to a process without providing authentication data for the new user ID. You can reset user password, even though you cannot decrypt to know what the password is, but you can change it. Then you can start or shut down or restart the system itself. So now, what are the key takeaways from what we have learned this morning, today? We have learned about that Unix exists in many variants, and they are referred to as Unix-like operating system. And we have the BSD and the Xenix variants of Unix, though we should know that these two variants do not conform with the SUS standard. And other operating systems that emulate Unix, which we refer to them as Linux, and Linux, we of course know that they have different distributions today. So to be considered a Unix variant, you have to be able to use the Unix trademark, and then that means you have to be compliant with the SUS standard. So what are also the key takeaways again? We know that we learned about the architecture of the Unix system, and that this comprises of the hardware, comprised of the kernel, it comprises of the shell program, and then the command processes. Also, Unix security model comprises of the user or user groups, and also is comprised of user account information and then the root user, talking about the privileges. Then network operators prefer Unix or Linux system for different uses. An example of such is that it runs on low cost. As compared to other enterprise solutions, operating system, Unix is relatively cheap to run, and then the several network vendors use Unix or Linux software. So that is it for now, and let's go to the next part that talks about introduction to Linux, FreeBSD, introduction to FreeBSD. That is the particular operating system of Unix I'll be considering in this course. So we'll be working with FreeBSD, particularly for this course. Now, what are the objectives that we are considering for this unit? We are looking at the main features and advantages of FreeBSD. Also, we'll be describing the file system and directory architecture of FreeBSD. Also, we'll be doing our best to explain the different ways of installing software on FreeBSD. Now, what is the overview of FreeBSD? Like we have learned in the previous unit, we learned that FreeBSD was developed by academics in University of California, Berkeley, and FreeBSD is a variant of was developed, let me use the word, was developed from Unix source code, even though it does not comply with the standard, the SUS standard, and thus it cannot use the Unix trademark, but then it came directly from the Unix source code. FreeBSD is now we refer to it as Unix-like because it does not use the Unix trademark. So FreeBSD is a Unix-like operating system, and it is derived from BSD, that is the Berkeley Software Development, and it is a version of Unix that was developed at the University of California, Berkeley. Just like any Unix operating system, FreeBSD is robust, it's stable, and it's a powerful operating system. And just like I've been repeating, it does not comply with the SUS standard. But instead of FreeBSD being just black and white, it supports graphical desktop development. So you can use it just like use your Windows. It supports environments such as the KDE, the GNOME, the XFCE. And though for the duration of this course, we will just be using FreeBSD, interacting with it using the command line interface. So we will not be using any graphical interface with it. So what are the advantages or what are the features of FreeBSD? One, FreeBSD has some distinct features and advantages. The first one says it uses the POS system. It has one of the best package manager systems available on any operating system. It's easy to update and it contains thousands and thousands of applications. Another advantage of FreeBSD is that it has what we refer to as the rc.conf file. This file provides for a single point to configure settings such as the host name, the IP address for all available network interfaces on the system, and the services to be initialized at the system booting time. So from a single file, you can perform all these modifications in FreeBSD. Also, it provides configurations for automatic repair of the file system at boot should any discrepancy be detected. Another advantage of FreeBSD is that it's flexible and reliable. It is fast, it is stable, and it is secure. It's secure in the sense that it can easily be customized for specific services. And by default, FreeBSD comes with 3 different firewalls. So you can choose to use all 3, you can choose to use 2, you can choose to use even just one. We have the IP firewall on it, IPFW, we have the IP filter, IPF, and we have the packet filter, PF on it. So most organizations, for example, WhatsApp, leverage on FreeBSD because it has a good record uptime. Few years back, the oldest server to ever run without shutting down is FreeBSD, and it ran for 18 years and 10 months. From 1997 to 2016, it was up, it was not shut down, it was not rebooted, it has been running successfully. So these are other examples of products that actually use FreeBSD as its core. We have the Netflix, we have the some gaming system, we have, and then software distributions that are available on FreeBSD, email, whatever you choose to use it for. FreeBSD has provision for it. And you mentioned also the advantages of FreeBSD and then FreeBSD architecture. It has a partitioning concept. So the partitioning concept for FreeBSD is that when you want to install FreeBSD, it has provision for auto partitioning. Now, what is a partitioning concept for FreeBSD? This partitioning is the act of dividing a hard drive into multiple logical storage units, which we also know as partition. So as to treat, the essence is to treat one physical hard drive as if it is multiple disks. So partitioning enables the use of multi-boot setups, which allows users to have more than one operating system on a single computer. Now for FreeBSD, when you want to install FreeBSD, FreeBSD also has auto partitioning installation available on it. And when it does auto partitioning, it simply slashes the partition space that you want to install the FreeBSD into other smaller partitions. An example, we have like, I think 5 main partitioning for under FreeBSD auto installation. We have the root partition, which contains the content and the size of the root partition that is enough for it to boot, to restore, to recover, and to repair the system. Also, we have the swap partition, which simply holds space for virtual memory. And we have the var partition, the variable also for keeping variable files such as logs, mails, pools, and the likes. And we have the temp partition where you keep temporary files. And also we have the user partition where it contains the user home directory. So it is in that partition that you can create directories of or what Windows refers to as folders for every user created on that operating system. So when installing software, like I said earlier on FreeBSD, you have 2 options, either install via FreeBSD ports. The ports, like we said, it has quite a huge amount of applications pre-installed on it. And we have the packet, FreeBSD packet. also known as the PKG. So you can also install particular command application using the FreeBSD packets. Also, the command is PKG. For example, if I want to install maybe Zoom on FreeBSD, all I need to use the command from the command shell, the CLI, the PKG install, then Zoom. PKG installs Zoom, and then installs the application for me with every dependency that is needed. I don't need to have pre-knowledge of interacting with Unix or Linux for me to run that. It has all the dependencies that will make Zoom to run successfully on that FreeBSD machine. So, and then this, like I said, second one for ports, though it takes a lot of time, you use the source code and the like, it downloads the extract before it installs. So, and like I said, the PKG makes installation easy. It contains pre-compiled copies, and then it runs it without me needing to know too much about the configurations or the dependency that is needed for that particular application to run. So FreeBSD system setup is initialized. Then now, what are the key takeaways from this learning? This complete module 1. So under the introduction to FreeBSD, we've learned that FreeBSD is a Unix-like operating system simply because it does not comply with the SUS standard, even though it was developed from the source code of Unix. FreeBSD has been used to develop many different product and software distributions, such as the Sony PlayStation 3 and 4 video game consoles, the Panasonic 2010 TV models, Nintendo Switch video game console, and Netflix Open Connect appliance. By default, FreeBSD automatically creates partitions and use the auto as the installation point. It needs, and unless you choose to do it manually, and of course, you know what you're doing. Also, software can be installed in FreeBSD using the POS system or the package install command. Most Unix or Unix-like operating system contain a form of online software documentation known as man pages. So after any installation of any Unix and you need to run a particular command, for example, the PKG, and you don't know how to use it or what, yes, you don't know, you need more information on how the commands run. When you type man from the terminal or the command line, you type man, then that command. It opens like a document for you, telling you everything that you need to know about that particular command or how it should be used. So thank you so much. This completes the module 1 of the network operations, and in it we have talked about introduction to Unix and also introduction to FreeBSD, which is actually the main operating system that I'll be using for the duration of this course. Thank you very much. See you at the next class or live session for the next module.